If you look at the URL of a YouTube video, it will have an 11-digit ID next to it. These IDs tell YouTube servers what video and information to send to your browser. Believe it or not, there are a lot of YouTube videos that are unlisted. This means that only the people with the link can view the video, and it can't be searched for or recommended. Yesterday, I had an idea that could grant me access to random people's unlisted videos, as well as any other video on the platform, as long as it isn't private, meaning only accessible to the original uploader. I would design a simple Python program to generate random YouTube links and automatically detect if they are valid. So I first had to figure out exactly how YouTube generates their URLs. It turns out that they use what's called base 64, which, I'm simplifying here, is a counting system made up for computers to count to 64 in a single character, symbol, or letter on the keyboard. Now usually when we think of counting to 64, we usually count up from 1 to 64. Simple. In base 64, things are a little different, in that numbers go from uppercase A to Z, then to lowercase a to Z, then from numbers 0 to 9, and finally to reach 64, 2 more symbols. Usually these symbols are plus and forward slash, but those things get a little dicey when in a URL, because the URL uses forward slash to indicate different pages in the website, and plus for other things. So instead of plus and forward slash, YouTube uses underscore and dash. Simple enough. Now, instead of counting from 1 to 64, it actually counts from 0 to 63. Not really important, just thought I would clarify. So when inserting a 0, instead of putting a 0, YouTube puts a capital A. Instead of inserting the number 45, YouTube uses a lowercase t. Now, to generate YouTube IDs, all I have to do is make an array storing all the base 64 characters. Now to generate a random string of them, I will create a function which has a for loop that executes 11 times, the same number as IDs in a YouTube video. Before that, I will create a variable called output equal to the string of letters, known as a string in programming, that spells out a short URL for YouTube, which is youtu.be, and then a slash and the ID. This redirects to the YouTube website, where it'll play the same video with the ID. So I can take the string and put the ID on top of it. How I make this ID is with the for loop, by generating a random number, in this case an integer, which is a whole number in programming, between 1 and 64. I then take that number and put it inside the array, and that will pick the random lucky base 64 letter slash number slash symbol to put after the existing URL in the output variable. It then does that same function 11 times, and returns the string as an output to the function. Now, if I call this variable in an infinite while loop, meaning that the program will continue to call this function until I stop the program, you will see that I have a lot of new YouTube URLs. However, these are random, which means that they aren't actually YouTube links. When a YouTube video is created, YouTube does the same operation, and then checks if a video with that same ID has been created. If it has, then it'll redo the operation until it gets a new ID, and if not, it will create the video. So when we do this operation, we are most likely creating a new YouTube video ID for a video that hasn't been created yet. That means that this function has a capacity to create existing YouTube links, but will most likely create non-existent links. So we need to implement a way to check if the video exists or not. So how do we do this? Well, we could use YouTube's own API, but I have no experience with creating API keys or whatever. And I prefer to make my way more external. Now thinking about it in hindsight, using YouTube's own API probably would be a better and faster way of checking this, but I digress. I used what's called Selenium, which is basically an automatic browser that does tasks for you. It's pretty useful at things like this. So I set up a basic check if in the URL that we randomly generated that it connects to, if there's a class in the HTML named StyleScope YouTube Player Error Message Renderer. This class is made when there's an invalid YouTube video ID in the URL. Perfect. So when Selenium detects that this class exists, it doesn't throw an error at you. However, if the class does not exist, meaning that there is an actual YouTube video in the ID that it generated, or more likely the connection had some sort of issue or timeout, it throws up an error, stopping the whole program, which is not ideal. So I used what's called a try and except statement in Python to stop it from killing the program. How a try statement works is it tries some code, and if there's an error, then it executes code in the except statement after it. If it doesn't throw an error, then it will either not execute code, or if there's an else statement after the except statement, it'll execute code in that. So I did exactly that. In the try statement, I asked the browser to find the certain class name in the HTML. if it did find that class, it would tell the program that it's invalid and to generate a new link. If, however, it is a valid link and gives back an error, because it could not find the class name that shows on the website that it's an invalid ID, then it would write the valid link in a notepad file called validlinks.txt. And that's it. The program can now run and automatically filter out the bad links and put the good ones in a notepad file. But how difficult is it to actually acquire a valid link? Well, I ran the odds through a percentage calculator, and the results kind of shocked me. So because of the 11-digit ID and the 64 character combinations for each digit, the possible amount of IDs would be 64 to the power of 11. That would be 73 quintillion, 786 quadrillion, 976 trillion, 294 billion, 838,206,464. So how many videos are there on YouTube? Well, according to merchdope.com, the first result of a Google search, there's about 5 billion. So if you throw that into a percentage calculator, it tells us that the program has a 0.00000006776263605111016% chance of getting a valid link. To put that small of a number into perspective, you have a 0.000081833060556464648% chance of getting struck by lightning. You also have a 0.000071511238420185116% chance of winning the lottery, and a 0.000015105619199406354% chance of choking and dying this year. That is, if you live in the US. So if you're lucky enough to get a valid link, then you better start blowing all your money on casinos as well, because you're probably going to win those as well. Still, this project was a ton of fun to make and a great way of learning coding for me. The GitHub link for the script is in the description, and I also want to give a huge thanks to Tom Scott, whose video on YouTube Ids helped me out a lot to understand how they work. That will also be in the description, and in the end cards if I can figure out how. That's been it for me. Thanks for watching.